This is the reading video for chapter 14, and we are starting a unit on probability. Now, I just want you to know that many students struggle with the ideas of probability. Not that you will, but many students do. So I want to make sure that you're spending enough time in your reading, going over the activities in class, spending time on these ideas that you really understand it, because I don't want you to struggle like many students do. Okay? The book starts off by talking about random events. For example, whether or not you have to stop at a stoplight could be thought of as a random event. Okay? Or whether or not you make the train or you have to wait for the train. It's a random event. And you can think about random events in terms of probabilities. Okay? Before we do that, we need to talk about some terms that are used in probability. For example, a trial. Okay? And a trial is when we observe a random phenomenon. Okay? For example, flipping a coin would be an example of a trial. Okay? The outcome would be whether or not we flipped it heads or tails. Okay, so the trial is flipping the coin. The outcome is was it a heads or was it tails? Now, we can combine several outcomes to form an event. For example, if I flipped a coin twice, getting heads twice would be an event, or getting tails twice would be an event. Okay, or another example of an event would be rolling dice and getting 2 ones, or getting a 6 and a 1 would be an event. Okay. The collection of all possible outcomes is called the sample space. Okay, you probably have heard that term before, but the sample space is all possible events. And we use the letter S, capital S, to talk about the sample space. Okay, next is a really important idea that you probably have not heard about before, and that is the law of large numbers. Okay, it's a really important idea. It is the idea that in the long run, the relative frequency of an event will get closer and closer to a single value. So, for example, if you're flipping a coin, we don't know if your first flip will be heads or tails, but we know that if you do it over and over and over again, in the long run, you'll get heads about 50% of the time. Okay, and that's the law of large numbers. Okay, that in the long run, if you do it over and over and over and over again, in the long run, you'll get the relative frequency will get closer and closer to a single value. Okay, connected with that idea is this idea of the law of averages, which actually doesn't exist. And that is, if I flip the coin 100 times and happen to get 55 heads instead of 50 heads, you may think that I'm more likely to get tails to make up for the fact that I've flipped more heads. And that actually is not true. There's no way that the coin can remember what happened when it was flipped. Okay, so that idea of the law of averages doesn't actually exist. Some students get confused about that idea. Okay, now modeling probability is what we're going to next. Okay? And I'm pretty sure that you're familiar with the ideas of theoretical probability, where you take the number of outcomes in an event, okay, divided by the number of total possible outcomes. Okay, for example, flipping a head on its coin would be 1 out of 2. It's looking at one outcome out of 2 possible outcomes. I know you're familiar with that idea already. Okay, just to remind you that the probability that a number is between, the probability of an event is always a number between 0 and 1. Okay, 0 is if it will never occur, and 1 if it will always occur. Okay, and also be aware that the set of all possible outcomes is S. So the probability of getting something in your sample space will be 1 because that would always occur. Okay, now are some ideas that you probably are not as familiar with, and that is the idea of the complement. Okay, if I have an event like rolling a 2 on the dice, then the complement of that event is everything else. So rolling a 1, 3, 4, 5, and 6 would be the complement of rolling a 2. Okay, which is a very useful tool for us. So if I wanted the probability of rolling a 2, it is 1/6, but it's also 1 minus the probability everything else happens. Okay, and this is very useful for us when finding the probability of an event is kind of difficult, but the complement is much simpler. Like we'll look at applications like this in class. Okay. Another thing you need to be aware of is the disjoint addition rule. Okay. If two events are disjoint, there's nothing in common, then the probability that A or B will happen will be the probability that A happens plus the probability that B happens. So for example, rolling a dice, the probability that I roll a 2 or a 4 would be 1/6 plus 1/6 or 2/6 or a third, because I'm adding up those separately because they're disjoint events. Make sure that you only use this when they are disjoint. In the next chapter, we'll talk about what to do if they are not disjoint. Okay. Also, if two events overlap where they can occur at the same time, and you want to look at the probability that two events happen at the same time, you can take the probability of one times the probability of the other, and that'll give you the probability that they both happen. Okay, but you also need to make sure that those two events are independent, meaning that the chance of one happening does not affect the chance of the other happening. Okay, so at the very end of this chapter, there is a step-by-step example about probability, about M&Ms. Make sure you go over this step-by-step example, as it is a really good application and shows you a lot of the ways of using the ideas in this chapter. Okay, so again, these ideas many of them are new, they're complex. Spend some time reading this and focus on the points that I highlighted in this video.